Be strong.
Yes, in today's video, we are going to read the chapter 4 of NCERT Curiosity book, Exploring Magnets. Okay. Reshma lives in a coastal town of Kerala and is very fond of writing short stories. Her grandmother loves listening to her stories, so Reshma was writing a new story to share with her grandmother on her 60th birthday. The story was based on a ship carrying spices from Kerala for trade in the olden days. Reshma was aware that in those days the sailors used stars to find directions at night, but in her story a situation arose wherein the sailors got caught in a storm with an overcast sky and stars were not visible, where stars were not visible. Reshma could not take her story forward as she could not think of a way for sailors to find directions. She searched for information on the internet and her school library. She learned that the travelers used a device known as a magnetic compass for finding directions. See, there is the image of a magnetic compass that is used to find directions. Reshma had seen pencil boxes and purses which had magnets to keep them closed. A writing board in her school also had a duster with a magnet, but she had never looked at those carefully. She now became curious to learn more about magnets and magnetic compasses. Okay, let's see what are magnets and magnetic compasses. The magnets used by sailors in the olden days were based on occurring magnets known as lodestones. Okay, lodestones are magnets that occur naturally, not by man-made, which were discovered in ancient times. Later on, people found out that magnets could also be made from pieces of iron. Nowadays, we have magnets made of different materials. The magnets that you find in your school laboratory and those used in pencil boxes, stickers, toys are all artificial magnets shown in the figure 4.1. See. Okay. The magnets can be of various shapes, some of which are shown in figure 4.2. See, like U-shaped magnet, bar magnet, a ring magnet. These are man-made magnets. Okay. Let's read about magnetic and non-magnetic materials. Okay. This is an activity to find which materials are magnetic and which materials are non-magnetic. See, there are materials like these nails are magnetic materials. This handkerchief is not a magnetic material. Okay. So in this activity, you have to see an object and write its name here, and you have to find out from which material the object is made. And first you have to see write your prediction that it is magnetic, attracted by magnet or not. And then you have to actually check by taking a magnet, that it is a magnetic material or non-magnetic material. Okay. Okay. So this is an important point. You have to highlight it. The materials which are attracted towards a magnet are called magnetic materials. Okay, whereas the materials which are not attracted towards a magnet are called non-magnetic materials. Okay, poles of magnet. Okay, activity we will do later. Okay, these ends of the magnet are called the two poles of the magnet. Like for example, okay, we will take a magnet. See, the magnet has two poles, south and north pole. So these poles have higher chances to get attracted by magnetic materials. Okay. See, the iron fillings are sticking at the poles of the magnet. Some iron fillings are sticking in the middle of the magnet, but mostly in the poles of the magnet. Okay. These ends of the magnet are called two poles of the magnet, the north pole and the south pole, which I have told you. Most of the iron fillings stick to the poles of a magnet of any shape. Yes. Okay. It is not possible to obtain a magnet with a single pole. Yes, highlight this point. This is an important point. If a magnet is broken into smaller pieces, north and south poles always exist in pairs. Like if I break the magnet from the center, it will have two more new poles. Like this is south, and this will be north, and this will be north, and this will be south. Okay. Finding directions. Okay, how to find directions to a magnet. Okay, this is the activity. In this, I will tell you in brief. In this, first we have to take some books and a bar magnet, paper, and a rope. First, we have to tie the magnet with a rope and keep it like that shown in the figure. And then we have to mark the north and the south direction on the paper. And when the magnet will move, it will show the directions. And how, if you are asking me that how it will show directions, it will show through the Earth's magnetic field. Through the help of Earth's magnetic field, it will show the directions. Okay. A freely suspended magnet comes to rest along the north-south directions. Yes, uh, a magnet that is freely suspended comes to only north and south direction because it has two poles, north and south. The end of a magnet that points towards north direction is called the north-seeking pole or the north pole of the magnet that I have told you. The other end that points towards south is called the south-seeking pole or the south pole of a magnet. Okay. Okay, a freely suspended magnet rests along the north-south direction because our Earth itself behaves like a giant magnet. Yes, and it has also a magnetic field. Okay, next. Repeat this activity with a small iron bar in place of the bar magnet. What do you observe? Does it always rest along north-south direction? It does not. It can rest along any direction. Yes, this is the main point, and you have to highlight this. This implies that only magnets rest along the north and south direction. This activity provides us with a way to test whether a piece of metal is a magnet or not. Yes. Okay, see, this is an image of a magnetic compass. And it has also a magnetic needle that shows the direction. Okay. The property of a freely suspended magnet to always rest along the north-south direction is used to find directions based on this. A small device called a magnetic compass was developed in olden days for finding directions. It has a magnet in the shape of a needle which can rotate freely. Yes, shown in the figure 4.6 that I have told you. See, there is a magnetic needle that moves freely. The needle of a magnet compass indicates the north-south direction. Yes. Okay, the compass is kept at a place where we wish to know the directions. Yes. After some time, the needle comes to rest in the north-south direction, and the compass box is then gently rotated, rotated until the north and south marked on the dial are aligned with the needle. Okay. Now all directions at that place are indicated on the dial. Okay. Let us construct. Okay. We will do this activity later. Attraction and repulsion between magnets. Okay. You will see that unlike poles of two magnets, that is the north pole of the of a one magnet and the south pole of another magnet attract each other. Okay. The like poles, that is either the north pole, that is either the north poles or the south poles of both magnets repel each other. Okay, so if we say that one magnet has south pole and one magnet has north pole, so it will attract each other because the unlike poles attract each other. But if we say that south pole and south pole will not attract each other, this paragraph says that only. Okay, this is also an activity. Okay, see, this is an important activity. I will tell you in brief. First, we have to take a compass, and then we will put the compass on our table, and also we will take a bar magnet or any type of magnet. But we can take bar magnet. Okay. After taking the bar magnet, you have to put bar magnet on anywhere. So it will point the bar it will if the north pole of the bar magnet is closer to the north pole of the magnetic needle of the compass, it will repel each other, that I have told you in the previous paragraph. Okay, but if the south pole of the bar magnet is closer than the north pole of the magnetic needle, it will attract each other because unlike poles attract each other and dipoles repel each other. When the north pole of the magnet is brought closer to the north pole of a compass needle, it moves away. Yes, I have told you that. Okay. It can also work if we put a piece of wood in it, because the piece of wood has a it is a non-magnetic material, but magnetic field can pass through the non-magnetic materials also. Okay. Okay, this is an activity observing the effect of magnet through non-magnetic materials. Okay, this in this activity, materials placed between the magnet and the compass needle. That in this activity we can see that if we will see that if the magnetic field passes through them, it is we have to take it right, and if it not passes, we have to take cross. Okay. Okay, fun with magnets. Okay. After learning about magnets, Reshma was excited and decided to set up some fun activities using magnets at her school fair. You may try making these yourself and may also think of some more fun ideas. Okay. Can we make a garland? Shown in figure 4.11. Okay, see, the pins are attracted by a magnet, and so they are magnetic materials. So they are sticking line by line, and form a garland. Okay, these are also some activities like this paper pen uh, is attracted to a magnet, so it can move anywhere where it is a magnet. Okay, these two cars that has magnet upside, so they will attract each other. But if the magnets poles are same, they will repel each other. So this car will go in direction, left direction, and this car will go in. The second one will go in right direction. Okay. And now the chapter is finished. Now we will do the exercises. Okay, unlike poles of two magnets attract each other. Yes. Whereas like poles repel each other. Okay, the materials that are attracted towards a magnet are called magnetic materials. The needle of a magnet compass rests along the north-south direction. A magnet always has two poles. State whether the following statements are true or false. A magnet can be broken into two pieces to obtain a single pole. No, false. Similar poles of magnet repel each other. True. Iron filings mostly stick in the middle of a bar. False. A freely suspended bar magnet always aligns with the north-south direction. Yes, true. Okay. This north and north repulsion. Okay. North and south attraction. And the south and north will attraction, and this north, south and south will get repulsion. Okay, so the chapter is finished. If you want more videos and if you want the doubts, if you have doubts, any doubts, you can tell in the comment section. And so, bye bye.